and then divided by 100, so the acceleration must be 1.07. Hello everyone, and welcome to the final part from Forces and Motion Basics. In today's video, we're gonna talk about acceleration. If you miss any of the last 3 videos, check them out in the Science Simulations playlist. We talked about the net force, motion, and friction, and the final part for this specific simulation from PhET is going to be about acceleration. So this section is similar to this one, except here you can also see the acceleration. And to make it easier to understand acceleration, I will cancel friction. Now if I push this box with 50 Newton, you can see that the sum of forces, because it's the only force that made by this robot, is 50 Newton. And you can see it's speeding up, and we call this acceleration. Now how can you measure the acceleration, or how can you calculate it? You can use Newton's second law, which states that acceleration equals the force divided by the mass. Now this guy fell down, so I need to repeat again and show you the acceleration. Let's push it with 50 Newton. According to Newton's second law, the acceleration equals force divided by the mass, and the force is 50 newtons and the mass is 50 kilograms. So my acceleration will be 50 divided by 50, which is 1. So what does 1 meters per second square mean? It means that for every single second, the speed is increased by 1 meters per second. Now what if it was moving to the right like now, and I want to slow it down? So what should I do? I should push to the left. Slowing down or pushing in the opposite direction will cause a negative acceleration. Why negative? Because it's the opposite of motion. Let's see. Now because I made 100 Newton force, 100 divided by 50, the acceleration is 2. Why it's negative? Because it's to the left, or the opposite of the motion. Now it will stop, and then it will start accelerating to the left. Why still negative? Because acceleration is a vector, and we consider the right direction is positive and the left as negative. Now what if I put this 200 kilograms? Can you tell me how much force I need to make 2 meters per second squared acceleration? If I make 100, I will only get 0.5, even though I'm making 100 newtons, but because the mass is so big, it doesn't accelerate that much. So I need to make 400 newtons, because 400 divided by 200, this is 2 meters per second squared acceleration. Now what if I push this with 100 newtons? You expect to get 1 meters per second acceleration. Okay, that's easy. But what if I make this much friction? Do you think if I push this with 100 newtons, I will still get 1 meters per second squared for the acceleration? Let's see. It doesn't even accelerate. Why? Because there's friction. Friction acts the opposite of the applied force, and it's exactly the same, so the sum of the forces is 0. Let me make 200. Now with 200 Newton force, you did not get 2 meters per second squared acceleration. Why? Because there's friction. And Newton's second law says the acceleration is not just any force divided by the mass, is actually the net force divided by the mass. So how can you find the acceleration? You must subtract 200 minus 87, get the net force first, divided by the mass, you get the acceleration. Now I'm not pushing, I'm not making any force. Why do I have acceleration? Because of friction. Friction is slowing this object down. since there's a force or a net force, there must be acceleration. 87 divided by 100, that's 0.87. Negative because it's to the left. And now if I increase the friction to this much, even with 500 Newton, I just got 2.2 meters per second squared, because you always have to subtract friction. But without, I got 5 meters per second squared, and that's more than double when I had friction. Check the link of this game in the description. Try different masses and different amount of forces. What you could do to test yourself is hide the acceleration first, then choose the object you like. Also, you can add friction if you want to make it more challenging. Then make your force. So 276, 124, what is my acceleration? Divide 124, that's the net force, by 90. You should get 1 point something. Calculate and then check. If it's the same answer, you are on the right track. You could also do it a level by level. For example, to start without the acceleration and to start without friction. And I would also recommend you to start with this 100 kilograms. Why? Because it's easy to divide by 100. Now make your force, make it whatever you want. Let's say 200, divide by 100, check, did you get the acceleration correct? If this is easy, next level, make some friction and then do the same thing. Make your force, don't check this force or this one, check the net force, the green one, or the sum of forces. And then if you still get it correct, then you can make it harder. How can you make it harder? You can hide the sum of forces. Then you don't see the sum of forces. How can I find it now? You subtract 150 minus 43, you would get 107, and then divide it by 100, so the acceleration must be 1.07. And then you can check your answer. That's it for today. See you in a new video about a new simulation or game from Science Simulations. Subscribe and share for more. Pandabood